let's understand disaccharide now. Now in disaccharide, the best example that I can take is of sucrose. Now in case of sucrose, sucrose first of all is combination of glucose and fructose. 2 OH, 1 of glucose and 1 of fructose. Loses water and forms glycosidic linkage. Now mind you, it was OH over here. Alright, we are talking in terms of alpha. Alpha I told trans. So just assume it, this is H. Don't have a feeling that this H is attached to this O. No, this is O. Alright, and this is H attached to first carbon, and this was OH over here. And even in case of fructose, it was OH over here. So in case of glucose, O and OHs are away, we call it as alpha or trans. Alright, now whereas in this case, CH2OH is down and OH is up. So OH is very close to O in case of fructose. So whenever it is close, we call it as cis and it is beta. Now what has happened is OH of this and OH of this got condensed, got dehydrated rather, and formed a linkage, O linkage. Now we know in organic chemistry, if it is OCO, we call it as etheric linkage. But in this case, we call it as glycosidic linkage. Alright. So this was alpha glucose, beta fructose. So, and this OH was attached to first carbon and this OH was attached to second carbon, as we saw in case of fructose, right? Second carbon, this OH was attached to second carbon, and these two combined, these two got dehydrated and formed the glycosidic linkage. So it's known as alpha beta, alpha of this, beta of this, alpha of this, beta of this, and position is 1, 2. So alpha beta 1, 2 glycosidic linkage. Alright, that's what is sucrose. Now this sucrose, very interesting. This sucrose, when we dissolve it in water, with bit of acid, this gets hydrolyzed and this comes back to its original state. Alright, original state is glucose and fructose. Now this glucose which is there, obviously we get alpha glucose, and here we get beta fructose. Alright, now rotation, optical rotation of this molecule, that is sucrose, is plus 66.5 degree. Whereas on hydrolysis, this breaks up to glucose and fructose. Now glucose has optical rotation plus 52.7 and this has optical rotation minus 92.4. Alright, now this is obviously dextro and this is levorotatory. I had told you whenever it is towards the left side, we give negative, and whenever the optical rotation is towards the positive side, or whenever the plane polarized light is shifted towards the right side, it is positive, and we call it as dextrorotatory. So this forms dextrorotatory and this forms levorotatory, plus 52.7 and minus 92.4. Whereas initially, as soon as we dissolved sugar, the rotation was this, but after hydrolysis with a bit of acid, these are the two rotations. So net result of this is what? Obviously negative. So the net result is levorotatory. Now this is the reason. So what we found is sucrose, which was dextrorotatory, on dissolving it in water, acidified water, it changed to levorotatory. And why did it change to levorotatory? Because of individual rotation. Alright, on summation of individual rotations, we get net result as levo, and this is the reason why we call it as invert sugar. Alright, now let's get into understanding about reducing and non-reducing sugar.